Okay. Hi, good morrow, starshines. The earth says hello. So I found out I fidget a lot on camera, so I'm trying to not fidget. And also, this is an important conversation to have. I don't know how to tell you this, but you're gonna need to get a job. Okay, I feel better now. I'm kidding, but this is an actually kind of important conversation to have when it comes to engineering. So, you know how Ray always says you need to be creative? And I always say, absolutely not. No, 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 no. Well, where does this friction come from? It comes from the fact that engineering design is more methodical and mathematical than first meets the eye. And I'm just going to tell you the truth. I'm not going to shield you from it. In fact, we're just going to teach you how to do it. And this is what this video is about. So don't get lost and don't get scared. And also, to preface this, there's a reason why your salary is gonna be like 100K plus. No, it's not because you're hot. Okay. There's a reason why engineering salaries are high, and it's not because we're hot. It's because we have to do rigorous work, rigorous mathematical work. Okay. So I'm gonna go through this nice and easy. Nice and easy is the goal here. Okay. Oh man, my hair looks awful. Doesn't matter. Okay. Okay. Oh my God, I look like Quasimodo. Okay, fine. Maybe I should take them off then. I look like less like Quasimodo now. But yay! Engineering design a la me. Okay, where's my laser pointer? Nah, I don't need it. Okay, so this is engineering design in your official lingo. I hate it. I'll tell you why I hate it. It's because it's unclear. Identify need and define the problem are two of the exact sentences, but just using different words. I said it. I'm sorry. I do not care. Synthesis, nobody knows what that word means, except biologists. Preliminary design, detailed design, prototyping, and production. So you'll be exposed to this step, I want to say in MEE 3. This will be the first time you'll be exposed to all of this. And honestly, it's not quite sufficient to what you're gonna do in reality. So I'm going to tell you the truth because I'm bored. Okay. How do I do the next slide? Damn it. Hello? Oh, there we go. So engineering design in your lovely lead speak, aka me speak. So as you all know, I'm very blunt. So I'm just gonna give it to you straight. So here are all of your steps, and I'm going to go through them one by one very slowly because it's important. It's very important. Okay, your first three steps. What's your problem? What are you trying to achieve? How are you going to achieve it? The first two problems sound the same, but they aren't. Okay, so what is your problem and what are you trying to achieve are completely different things. What is your problem? For example, our problem is we don't know what our size is for the fin, right? And what are you trying to achieve? We want the submarine to turn at a reasonable angular acceleration without it flipping or anything, and thus killing our pilot. So yeah, there's a distinction between these two problems, and you ought to know it now. And what is the problem will be your biggest headache. This is the hardest part of the design process because if you do this wrong, everything else will be wrong. So, no pressure. Actually, no pressure. If you're just gonna do it again, just do it again. But it's not that deep. But it's not that deep, I swear. I'm just a little tired. Anyways, okay. Okay, God. God, I can do shit. Okay, yeah. So identifying your problem takes a little bit of time. It takes a little bit of cooking. So be patient with yourself. And yeah, we're trying to achieve. This is relatively easy. Step three, how are you going to achieve it? This is where we become Google engineers. And we just Google the hell out of it. Because. Okay. A lot of people probably have the same problem that you do, and they probably found a solution and they probably done it better than you. So why would you come up with something novel when you can look at other people's work? You know? Instead of saying that's cheating, we're just going to say we're standing on the shoulders of giants. See? Yeah. So this is where you, God, I don't have a stylus. So where you Google. Yay. Preliminary design and development. This is where it starts to get a little bit tricky, so you have to follow along pretty carefully. So I've identified one big part, which is ballparking. Ballparking, hot girl guessing. It's going to be a very important part of your career, is the ability to make an educated guess. Okay? Is a good skill to have in life, especially for my mechanical engineers out there, and maybe aerospace, but none of you are aerospace anyway, so it's fine. So the ability to make a hot girl educated guess, it requires time and experience, but I'm just going to go through what you're basically going to do every time you make a guess. Your baseline analysis is that you need to account for your environmental factors and also draw a free body diagram. Two steps. Environmental factors and free body diagram, right? So an example for environmental factor would be the temperature. How would that temperature affect the fluid? And you can make a calculation on that. Well, you know, right? Free body diagrams. Okay, I cannot stress this enough. This is very important. And every time you make a part, you want to draw a free body diagram just to get an idea what forces are acting on it and what you need. So never neglect this step. This is one of the most important steps you need to do. So yay. Okay. Then make proof of concepts. In your preliminary design, this is where you 3D print shit just to see if it works in and of itself. Because a lot of times you're gonna make something novel. It's an idea in your head, and you have an idea of how it works, but you don't know how it works in real life. That's where 3D printing and all that comes in. You gotta 3D print it, make sure to see if it works in and of itself, and then you proceed to the next step, detailed design. So this is where you pick the proof of concepts you like, and you kind of run with it. You run with it as in you refine your math based on the proof of concept you like. You should have a better understanding of the forces at play on the part. And you're gonna do your free body diagram and your hot girl math, and you're gonna refine your initial hot girl guess math. Okay. And here's the big one. You need to write code. You will need to write code to suss out the specs for your part. And we're gonna teach you how to do that. And the reason why you need to write code is because it's the most efficient way of sussing out the correct specs. That's it. Hi, editing Carly here. Yes, I did edit something, unfortunately. I think the reason why we're gonna use iterative design is best captured by this following meme from SpongeBob. This is the announcement.
Nothing's working!
Wait, SpongeBob! We're not cavemen! We have technology!
It didn't work.
Will be your ace when you go get a job. Yay! Okay. So prototyping. But that's where you actually make your part in the full specs just to see if it works. It's like the final testing. Yep. And then you finally make the damn thing. So it's like 7 steps, but it's non-linear, right? So basically, here's how it's realistically going to shake. Preliminary design, yay, it works. I like that part. I use the detailed design. Ooh, it doesn't work. I go back to this, and then I realize, oh crap, I identified the wrong problem and I have to do all of this again. Design is a very messy process. It's not linear. This is why your salaries are high. Don't forget that. Work is work, babe. Don't forget that. Okay. Next. Okay. This is the part where I want to emphasize because my professor didn't, or at least I didn't pay attention. No, I feel like she didn't. She did not. She did not. Okay. If she did, a lot more people would have passed her fucking class. Okay. Just saying. But iterative design, you're gonna use code, but I feel like a lot of professors and in general people are bad at translating code logic into human speak. So I'm gonna see how good I am at doing this. Ahem, ahem, ahem. So to make the code thingy, you need a few ingredients. First of all, your goal quantity. So what you want to achieve, right? Your question two. Your question two. No, not question two, point two. Damn it. Okay. And then your governing equation that spits out your goal quantity, right? Whatever that is. Could be an acceleration, could be an angle, could be a surface area, whatever. Whatever that is, right? And then your tolerance. Okay. Your tolerance basically is how far off do you want your calculated quantity to be from your actual goal quantity? Because remember, not everything is to the T and to the dot. So you have to decide the tolerance for yourself. I just gave a random example here, but you know, I'm gonna find out the basic or like standard tolerances later on when I have the time. Yeah, and also you have to find an initial guess. So that guess needs to be an educated one, but it's kind of a catch-22 situation because it takes time, experience to gain that intuition. So if you make an atrocious hot girl guess, does it matter? It matters if you ballpark on a napkin, but if you're gonna do iterative design, it doesn't matter because you eventually get to your number anyways, but your code will just run a little bit longer. Okay, here's the code logic. I'm just gonna try to explain it slowly because I am frightened too. Here, I move my butt to the other side. Yes. Let me continue. Let's see. So you're gonna find your goal quantity. So this will take place in your step two. No, actually step three in your preliminary design and your detailed design, right? It's because of what I said about like ballparking the math and refining the math. That's where you find your goal quantity. And then you make your initial hot girl guess. Could be anything. Okay. And then you're gonna plug in your hot girl guess into the equation that spits out your goal quantity. So here's the equation I came up with. So hot girl guess number, and then your calculated number, right? And then you're gonna compare your calculated number to your goal number to see how far off it is. So it's gonna be like some percent. Let's say it's like 5%. And then the function will repeat itself and you change your guess in an incremental manner until the percentage error arrives to your desired one. Okay, that was a lot. It's okay. You can watch it again. But yeah. So changing your x in an incremental manner would be like, oh, if your x is 5, your next loop would be 4, 3, 2, 1 until you arrive to the y you want, right? So that's the baby version. The real version is that your x will be changing based on your percentage error. And that's where we talk about numerical methods. 107 is actually important. Scrumptious. But anyways, for all of this iterating to work, you need to write a for loop or a while loop, which are just MATLAB functions. I'm going to teach you how to do it, right? and you're gonna learn some numerical methods to do all of this. Don't worry about it too much. I'm gonna teach you. You don't have to wait for 2 years later. I'm gonna teach you it like during the holidays, probably. You're just gonna go on YouTube and watch how I do it. And I'm just going to explain to you as simply as I could. And I have faith you can do it now because I don't think it's actually that bad. But I feel like a lot of people just explain shit poorly. And that's a them problem. It's a you problem. Okay. Okay. I think that's it. Okay, extra things to add. Okay, also design process. I heard this in class. I think it's important. I think we should pay attention to this. We always decide on geometry first, material later. And the reason is because you can always switch out the material, but geometry is predetermined through calculations. And why would you want to change your geometry based on your material? That's way too much math. Absolutely not. And also for your CAD drawings, I told this to the other chicken nuggets. What did I say? Always dimension from the left edge to the top edge. Okay. What do I mean by that? Here. So as you could tell, I fucked up. I got hasty with my dimensioning. So I actually dimensioned it wrong. But okay, here's what I mean. So your distance between the left edge, like this. You always want a dimension on the left edge and the top edge. It's a good habit to have. Have it right now. It will come in really handy 1 year later when I'm graduated and you need to be a slave at the machine shop. The reason is because your tool comes down from this side. So it'll be left and this side. So you want a dimension from your left edge and your top edge as like a best practice thing. Yay! That's it. That's it. And also a few notes about the MATLAB thing. Hello? Yeah, we're gonna teach you MATLAB. Don't worry about it. I did say before that you might want to learn about linear algebra before you go into MATLAB. I've decided to just tell you what the legal and illegal moves are. It's basically Sudoku. Okay, linear algebra is Sudoku. Think about it like that first. And I'm just going to tell you the legal and illegal moves, and I'm going to tell you the basic operations you can do, and then I'm going to teach you how to code it. It's going to be really easy, and also MATLAB is pretty important to learn. Don't neglect it. Please don't. A lot of people do, and low-key it screws them over really hard. They won't admit it. Don't listen to the Reddit code. And I think that's it. I think that's it. All right. I'm done yapping. See you later. Oh, I do have something to yap about. Um, so on Saturday, me and Ray showed you guys how to do our versions of ballparking. So I'm gonna show it on YouTube too, but I'm gonna private that video because duh. But for those of you who didn't go, ballparking is it's like a it's guesswork, right? But everybody has their individual way of guessing. So I'm just gonna show mine. And I'm gonna ask Ray to show his too. And then we'll go through it in detail. And I'm just going to justify the choices I made in my hot girl guessing. Yay! Perfect. Okay, I think I'm actually done. Kill, kill, kill. How do I end this? Right.